Hello folks, today we dive into the Promises galaxy. After many years in the JavaScript environment, I noticed that many developers don't know really well how promises work. Yes, they are using them, but without the real knowledge. So in this video, we will understand all the secret of this fantastic JavaScript part to handle our JavaScript async code in the best possible way in the future. So don't waste time and let's get started. Let's start from the fundamental. So a promise in JavaScript is a simple function that has three states: pending, rejected, and fulfilled. Pending means that the promise is ongoing. So this means that the promise is waiting for something. Rejected is when something went wrong during its execution, and this means that there is an error. Maybe let me give you an example. For instance, there is an error in the connection with your database or something like this, and in this case the promise is rejected. So means that you have an error during its execution. Last one is the fulfilled. Fulfilled is when the promise is resolved and you have a success of the promise. Let's see this example. For instance, in this case, I create a simple function called getPromise that returns a new instance of a promise. As you can see, the promise accepts a callback. This callback has two arguments. The first one is the resolve and the second one is the reject. Both are functions, so you have to use resolve or reject based on what happened during the execution of your promises. For instance, in this case, I create a simple set timeout with 2 seconds, and after 2 seconds, I'll check the math.random function, and if the result is greater than 0.5, the promise is rejected and return a new error, in this case a simple error with the error message. Else, the promise is resolved and return a string with the message success. Then, using this simple function, I call the getPromise. Now, as you can see in the myPromise variable, there is the instance of the promise. And then, using the then function, we can handle the result of the promise. They then accept two functions. The first one is the resolve function. So if you have to handle the success of your promise, you have to handle this first one function, as in this example. Else, if you want to handle the error, you have to use the second argument of the then function. In this case, as you can see, I handle the error message and I using the console error to show the message in the console, and the same is for the success. I use the console log to save to show the success message in the console. And now we can see the result in the console, for instance, in the terminal. So we can call node source 001 example. And as you can see, after 2 seconds, we have the result. In this case, the result is an error. And as you can see, the console show no error is the expected result if we have an error. If you try again, for instance, in this case is no again, but maybe the third one is a success. As you can see, in fact, the result here is success. And as you can see, handle promises is pretty simple in JavaScript if you know how it works. ECMAScript 6 has introduced two new keywords, async and await, and we can use async await to handle promise in a beautiful way. Before we see in the then method, using the async await, we can call a promise and handle it like a simple procedural code. As you can see in this case, using the async, we say to JavaScript that this function return a promise. And inside of this function, we can also use the await keyword. In this case, as you can see, I call the getPromise, and before there is a simple await keyword. In this case, using the await, we say to JavaScript that if this promise return a resolve value, assign this value to the success message. And in this case, the code base when the resolve happen, assign the result to the success message and print in the console yeah and the success message. What happens if the promise is rejected? In this case, using the try catch, we can catch the error of the promise. So if the promise is rejected, we can get the error in the catch, like in this example. And inside of the error, we have the rejected error raised by the promise in this case, and we can handle it. In this case, I simple using a console error, and I print in the console no and the error message. And then in this way, you can handle promise in a simple procedural way, like you are familiar when you work with non-async code in JavaScript. For instance, in this case, we can also see the result in the terminal. We can call node source and example 1 again. And as you can see, if the result is a success, in the console we have the yeah success message. We try again to have the error message. In this case, we have no error because the promise has rejected. And in this case, as you can see, in this way we can handle promise in a beautiful way, and understand what happened during the execution of the code is easier for the developer in this case. Okay, but the promise function has also other two important methods, the catch and the finally. So the get promise is always the same. So as you can see, in this case, there is a promise, the function return a promise with a timeout, and after the timeout, check if the math.random return a number greater than 0.5, reject the promise, else resolve it. Pretty simple. So before we see the then, and the then accept two functions, the fulfilled and the rejected. So the fulfilled is when is resolved, when the promise is resolved, and the rejected is when there is an error. But you can handle the reject also using the catch method exposed by the promise. In this case, the catch method accept another function. In this case, there is a parameter that this parameter contains the error rejected by the promise, and inside of this catch, you can do whatever you want to handle your error. The same is for the finally. So the finally is a function that will be called in case the promise is resolved or rejected. So in both cases, the promise called the finally. Imagine you have to handle the same stuff in case there is an error or is resolved. You can use the finally to handle this behavior, and you will be sure that the finally will be called in case the promise will be rejected or resolved. So now it's time to see this code in action. So for instance, we can call node source and the second example. As you can see, in this case, the result is pretty simple. The promise return is a resolve value, so call the then, so call the console log of yeah and the success method, and then call the finally. The same happens if there is an error. Let's try again, and as you can see, in this case there is an error, and the result is this one. So there is a no error. So as you can see, the catch is was running, and then the promise called the finally method, and that's it. It's pretty simple, but as you can see, the promise return three different methods that help you to handle the promise as you want. We can do the same also with the async function. So as you can see in this case, we can use the try-catch block, and using the finally, we can handle the finally state of the promise. So in this case, using the await, if something went wrong, the catch the error. In case everything will be okay, the success message get the value and call the console log with the yeah. And in both cases, after the execution of in this case, the print in the console, the JavaScript call the finally state, and in this case, print in the console finally. Pretty simple. In this case, it's easier for the developer understand what happened, because the try-catch block is common for it's more common for the developer. But now it's time to see this step on action. So let's open the terminal, source and second example, and as you can see, in this case, the result is resolved. So yeah, success and finally, and the same is if there is an error. For instance, in this case, there is a no error, and finally is the last one message. As you can see, in both cases, you can handle catch and finally, and also the resolve of the promise. If you use the async, maybe for some developer is easier to understand what happened, for other is better than. It's important that you understand how promise work, and then use the perfect syntax for you in all the cases. Personally, I prefer the async await if I can, but in some cases it's better also use the then and the catch and the finally method. Depend also on what you have to do in your code base, and how you want to handle some stuff, for instance. As I have anticipated before, we can also create a chain of promise. For instance, in this case, as you can see, I call the then many times, and every time I call inside of the then, I return a new value for the promise. In this case, the first one wait for a timeout of 2 seconds and return and call the resolve with the value 1. Then in the then method, the function get the parameter, in this case number. You print in the console 1 to understand the step and the value of the number, and return this value multiply by 2. The second time I call the then, same stuff. I got the function get the number, print in the console, and multiply the number by 3. And at the end, I call only the console log to see the last result. As you can see, you can create a chain of promise using the then, and return a new value in the then. Now it's time to see this stuff on action. So we can open again the terminal and call node source and the third example in this case. As you can see, after 2 seconds, I have the first yeah with the value 1, because the first resolve return 1. The second yeah is 2, because 1 multiplied by 2 is equal to 2. And the third is yeah 3. And the result is 6, because 2 multiplied by 3 is 6. And as you can see, you can create a chain of promise and call the then. You can handle it in a simple way. But what happens if in a step of the chain there is an error? You have to handle it using the catch. It's pretty simple. In this case, after in the second then, I directly throw an error with the new error with the message error. And at the end, I use the catch to handle the error in case there is an error during the chain. In this case, when this code will run in your browser or in your Node server, this is what happened. So the first step is create the promise and wait for the timeout of 2 seconds and resolve it with a value 1. Then call the then method and call the print in the console the number and the one and return the new result with 1 multiplied by 2. When the code arrives in the second then, throw immediately an error, in this case the new error with the message error, and the promise jump directly in the first catch that is in the chain, in this case the last catch, the catch in the last position of this code base, and handle it. You can handle the catch and maybe print the error in the console, or you can also maybe return a new value and continue the chain. If you return a new value in the catch, you can prevent to break the promise and restart a new then. As you can see, after the catch, you can call the then again if you want. It's possible because maybe you have an error, an expected error, and you want to handle it and maybe jump in the next step of the promise and handle it in a specific way. So it's time to see this code on action. So open the terminal, node, and source example 4, and this is the result. As you can see, what happened is this: the promise wait for 2 seconds, resolve the promise with the value 1, call the first then and return the value, and then when the second then throw the error, jump directly in the catch, and in this case I handle the catch pretty simple, printing the error in the console, and that's it. This is a pretty simple example of how you can handle a chain of promise and how to handle an error in case there is an error during its execution. Inside of the then, you can also return another promise and then wait until the promise will be rejected or resolved. So in this case, I create a chain of promise that start from a simple promise that wait for 2 seconds in a timeout and return a value 1. Print it and then return a new promise that wait for other 2 seconds and return the number multiplied by 2, and then the same call the print the value in the console and return another promise that wait for other 2 seconds and return the number multiplied by 3, and then the last is the then that print in the console the last number. I also handle the catch, but in reality, in this case, everything will be okay, and the catch is useless in reality. But as you can see, you can also you can use the then and return another promise inside of the then and create a chain of promise inside of using then and using the then and the catch if you want. And now it's time to see this code on action. So I open again my terminal and call node source example 5 in this case, and as you can see, after 2 seconds there is the first result, after other 2 seconds there is the second result, and after other 2 seconds there is the third result, 1, 2, and 3 as expected. And as you can see, using the then and the promise, you can create a chain of promise and handle it in serialize if you want, or in the next example we will see how we can handle it in parallel or in different way. Okay, now it's time to talk about 4 different method exposed by Promise in JavaScript that allow you to run Promise in parallel and have different behavior based on what you decide to use of this for method. The method are this, so I can call node source example 6, and the method are this. So the first one is the whole, the second one is the race, the third one is the all-settled, and the last one is the any. So before jump to the example, I want to show you how I can decide to create this example. So there are two different examples, one without promise rejected and one with promise rejected. So every example has 3 promises. So the promise is pretty simple. There are 3 promises. So the first one is a promise that waits for 1 second and return 1. The second one is the delay that waits for 3 seconds and return 2. And the last one is a delay that waits for 5 seconds and return 3. And this is an array of promise, as you can see. The promise is pretty simple. There is a timeout that waits for the millisecond and then resolve the promise. And the other example is an example with an array of promise, and one of them will be rejected. In this case, the second one. So as you can see here, there is another array with the delay of 1 second and return 1. Then the second one is a delay with error that waits for 3 seconds and then reject the promise. And the last one is a delay of 5 seconds and return a 3 as a value. I use these two array of promise for my example to show you how this method works in case of everything is okay or there is something went wrong during its execution. So now it's time to jump to the first method, that is the Promise.all method. Okay, the Promise.all, it's pretty simple. The Promise.all accepts an array of promise and wait until all the promise will be resolved. In case one of them will be rejected, immediately call the catch. Immediately the Promise.all will be rejected. Imagine the Promise.all another promise. So if is resolved, is a promise with the the fulfilled state. If the Promise.all will be rejected, is a promise with the rejected state. Pretty simple. And now, as you can see, the Promise.all accepts in the then a parameter. This parameter contains an array of value, and for each element of this array, you have the value returned by the promise in that index in the array of the promise you have passed to the Promise.all method. Pretty simple. So now it's time to see this Promise.all in action. So we can open again the terminal and call node source and this is 6th example. So if I call the Promise.all without error, as you can see, the first promise will be resolved, the second promise has resolved, and the third promise has resolved. And at the end, as you can see, the Promise.all has resolved, and the value contain 1, 2, and 3. And as you can see, the 1 is the value for the first promise, the 2 is the value for the second promise, and the 3 is the value for the third promise. But what happens if I call the Promise.all with error? As you can see, the first promise has resolved, the second one has rejected, okay, and immediately the Promise.all call the reject state, call the reject function. And as you can see in the catch, there is the all rejected message that I use for to show there is an error during the Promise.all execution. And then there is the delay of the last promise, in this case the delay with 5 seconds. It's important to spend some word about this. As you can see, the Promise.all immediately called the catch, but the last promise continue running. And it's also important to remember this in your code base, because if you use the Promise.all, all the promises will be parallelized, and if one of them will be rejected, the other continue its execution. And yes, the Promise.all return only return a rejected state, but in reality, if you maybe call a mutation, 3 mutation in parallel, you could have a state of your application that is inconsistent, because maybe you have three mutation that has resolved and one that has rejected. So maybe you expected to have a transaction of 3 stuff. In reality, you have two stuff changed and one haven't changed. So in this case, you have to understand if the Promise.all is what you want to use for your behavior. Basically, it's common if you have to call three API in parallel. You have to call 3 different endpoints to get some data. If one of them have a problem, there is a problem and you have to handle it and maybe show an error for your user, or maybe there is an error to retrieve. You have to call, I don't know, you can parallelize three query in your database, and in this case one of them have a problem. You have to raise an error because you don't have all the data to maybe handle your behavior in this case. So as you can see, Promise.all is fantastic if you want to handle promise in parallel and get only a value that contain all the resolve value for your promise, but you have to pay attention to use it in the right context. Now it's time to talk about the Promise.race method. The Promise.race method try to get the first resolve value from the list of the promise you pass to the list. Imagine you have three promises. The first one that will be resolved, assign the value of the resolved also to the resolve of the race. But if the first promise that return a state return a value is the promise that will be rejected, the promise race will be rejected. Let me show this in action, because maybe it's more easy to understand. So in this case, node source example 6, and we can call the without race. So without error, the race without error. In this case, as you can see, there is the delay of 1 second, and this is the first promise resolved. And as you can see, the race will be resolved after the first resolve of the promise. And then, yes, as you can see, as for the Promise.all, the other promise continue its execution, and after 3 seconds, the second promise has resolved, and the same for the third promise that after 5 seconds will has resolved. And that's it. So, but what happens if I call the race with an error? So in this case, the first the first promise that return a value is the first promise that is resolved. And as you can see, the race return the resolved value of 1. But if, for instance, I go to my promise, generate promise with error, and the delay with error has a delay of 500 milliseconds, and call again the race with error. As you can see, in this case, after 5 milliseconds, the second promise is rejected, and the race is rejected. As you can see, the race get the first value from the first promise that finish, and if the first promise is resolved, the race will be resolved. But if the promise will be rejected, also the race will be rejected. Pretty simple, but it's important to keep in mind this, because the race get the first promise that is completed in reality, and use its value as a result of itself. Pretty simple. Okay, now it's time to talk about the Promise.all.settled method. The Promise.all.settled method is similar to the Promise.all, but with a simple different approach. The all.settled return always a promise resolved, and inside of the value you have a list of the state of you have a list of objects that include the state of the promise and its value. For instance, if you have a resolved promise, you have a fulfilled object with a data that contain the resolved value. If you have a rejected promise, you have an object with a value with the state of rejected, and inside of the error you have the error of the rejected. And as you can see, in this case, the Promise.all wait until all the promise will be resolved or rejected, and then compose the result of for you, and then you have to understand if all the promise will be resolved, or maybe all the promise will be rejected, or you have a mixed situation where some will be resolved and some will be rejected. So it's time to see the all.settled in action. So now it's time to source, and in this case we have the example 6, and we can call the all.settled without error. In this case, as you can see, there is the first promise, the second promise, and the third promise, and then there is the all.settled resolved, as you can see here, all.settled resolved, and the value is an array that contains an object with the status fulfilled and the value, in this case 1, then the status is fulfilled and the value 2, and the status fulfilled and the value 3. But what happens if we call the all.settled with an error? So the first one will be resolved, the second one rejected, and the last one is resolved. As you can see here, the result is a bit different. So the first one, the first object is the status fulfilled and the value 1. The second one is the status rejected, and the reason is because there is an error, and here is the error. So there is an error because I raise an error, a new error, and so on. And the last one is the status fulfilled and the value 3. As you can see, the all.settled is similar to the whole, but permit you to understand what you want to do if there is a promise that has an error, or one or two promises that had an error, and you can handle it in a different way. Maybe you can retry or do something like this, and you have an idea of which promise has resolved and which promise have rejected. And that's it from the all.settled. Last but not the least is the Promise.any method. The Promise.any method is similar to the race, but with a small difference. So the Promise.race get the first promise resolved or rejected and use it value to understand the status of itself. So if the promise is resolved, the promise race is resolved. So if the promise is rejected, the promise race is rejected. In case of the Promise.any is a bit different. So Promise.any wait for the first promise resolved and return it as a resolve value for itself. If only all the promise will be rejected, in this case the Promise.any will be returned an error. So as you can imagine, Promise.any is fantastic if you want to get the first value of the first promise resolved. And in case all the promises will be rejected, in this case, unfortunately, Promise.any will be returned a rejected status. So now it's time to see the Promise.any in action. So open again our terminal and run the last example. So the Promise.any without error. In this case, as you can see, the delay, the first promise will be is resolved, and the result of the any is the value 1 because it's the first promise resolved. If I call the Promise.any with error, in this case, as you can see, in this case, the delay, the first promise is rejected after 500 milliseconds, but the any wait until the next promise resolved. In this case, the promise with 1 millisecond and is resolved with the value 1. And in this case, as you can see, the any resolved return 1 as a value. But what happened if, for instance, I go to this example and change all the promises with promises rejected after 500 milliseconds? As you can see, in this case, the promise any will be rejected because all the promises have rejected. And that's it. So in this way, you have learned all the way to handle promises in parallel and have different behavior in case on what you have to do. And basically, Promise.all is one of the most useful use method if you have to run API in parallel and handle it in your UI, or maybe you have to handle different query in your database, and you can use the Promise.all to parallelize them and get the result only when all the promises will be resolved. And now it's time to move in the last example to understand how to use a new feature that will be appear in a new version of the ECMAScript in the future. ECMAScript 2023 has introduced a new static method for promise called withResolver. withResolver is a method that permits you to get a promise and decide in the future when call resolve or rejected. Imagine you want to, I don't know, create something that wait for a promise, and in another part of the code that happen in the future, okay, in the part after of the await, not of the await but after your promise, you want to decide if you want to call the resolve or the rejected. Using the withResolver, you can easily do this. For instance, in this case, as you can see, I create also an example using a simple function, because the polyfill for this kind of stuff is pretty simple and easy. As you can see, the with resolver works in this way. So for instance, you have a let resolve and let reject. You can call this const promise and create a new promise that accept that have a callback with a resolver and a rejected function, and you can assign the resolve and the reject to these two functions, and then return a new object that contains the promise, the resolve, and the reject. Then you can use this function in a pretty simple way. So you can call Promise.withResolve, and you can get the promise and the resolve. And in this case, you have a set timeout, and maybe you can wait for a number of milliseconds. And after this this wait, you can call the resolve, and in this case, you can return the promise and decide in this part of the code where is when the resolve must be called. The same is for the reject. For instance, you can create a delay with error, and in this case, we can call the Promise.withError and get the promise and the reject. Call the set timeout, and after this time, call the reject method, and we can return the promise. So in this case, we can change the approach and not return directly the promise, but in this case we can create a promise and call the set timeout and decide when call the resolve and the reject. Pretty simple. I also create a pretty simple example, as you can see that in one case after I call the delay, and after 2 milliseconds there is a then with the print in the console the result, or the catch that print in the console the error. Pretty simple. The same for the with error. And as we can see this on action. So node source example 7, and we can call promise with resolve without error. So in this case, as you can see, after 2 seconds there is a resolved value. But we can do the same using the with resolver with error, and after 2 seconds there is a promise rejected, and pretty simple. Using this utility, you can handle in a very simple way. You can convert in a very simple way something that is not a promise in a promise. Maybe you need to handle a callback, an old code with a callback, and you want to transform it in a simple promise. You can do this without any problem. And I think this is a really pretty cool feature introduced by ECMAScript in the ECMAScript 2023. And I think that's it from Promise. So now it's time to go to the conclusion. And there you have it, fellow developer. We venture through the realm of JavaScript promises, conquering asynchronous challenge along the way. Now, armed with the knowledge, go further and build a seamless, efficient application that dances to the rhythm of promises. Remember, wherever you are a junior coder taking your first steps, or a seasoned pro refinement your craft, promises are your truly companion in the asynchronous universe. And before closing, don't forget to subscribe to this channel for many other awesome content. And if you enjoyed this video, please bump the like button below. That's all folks, see you soon, bye bye!